everyone, and welcome to today's webinar in the CERTUP and ESTCP webinar series. My name is Jennifer Nyman. I am a Principal Engineer at Geosyntec Consultants in Oakland, California, and the coordinator of the webinar series on behalf of CERTUP and ESTCP. I will be facilitating today's call. The webinar will consist of a brief overview of CERTUP and ESTCP by Mr. Timothy Tatro, followed by a list of upcoming webinars in the series. After Timothy's opening remarks, we will transition to the technical portion of the webinar. Today's event features two presentations on energy projects. On today's call, Mr. Kevin Marr from Power Analytics will present an overview of CERTUP and ESTCP-funded research on the Secure Automated Microgrid Energy System. Mr. Marr's presentation will be followed by a brief question and answer session. Then Mr. James Bach from IP Keys Technologies will present research to develop an accreditation process for DoD facilities to participate in automated demand response. His presentation will also be followed by a question and answer session. We will conclude the webinar with an interactive question and answer session with both speakers. Today's broadcast will be listen only. You may submit questions by using the chat box on the left-hand portion of your screen. You do not need to wait until the Q&A period to submit your questions, and in fact, we encourage you to submit questions in advance of that session. On this slide, we have provided a few suggestions in case you experience difficulties with the broadcast audio. Typically, any delay will be fixed if you refresh your screen or call into the conference line shown here. However, if you continue to have problems, please submit a comment using the chat box in the lower left corner of your screen. And with that, I would like to introduce Mr. Timothy Tatro, who is the ESTCP Program Manager for Energy and Water. Before joining CERTUP and ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim?
Thank you, Jennifer, and welcome everybody to today's CERTUP and ESTCP webinar. CERTUP is the Strategic Environmental Research and Development Program established in 1991 by Congress as a partnership between the DoD, the Department of Energy, and EPA. CERTUP's mission is to identify and address high-priority environmental science and technology opportunities that focus on DoD requirements. CERTUP funds both fundamental research as well as advanced technology development that ultimately impacts real-world environmental management. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental and energy technologies. These investments capitalize on past investments under CERTUP or other research programs that are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. CERTUP and ESTCP are complementary programs, with much of CERTUP research occurring in the lab and pilot scale, while ESTCP demonstrations are primarily at the pilot and field scale. There are 4 program areas in CERTUP and 5 in ESTCP. The Energy and Water program area is only in ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and resiliency, and weapon systems and platforms, are both CERTUP and ESTCP programs managed jointly by a designated program manager. Our webinar today is focused on research and demonstrations that were conducted under the Energy and Water program area. Energy and Water has essentially 3 main areas of research. First, smart and secure installation energy management, which the webinars today fall under. Efficient integrated buildings and components, and third, distributed generation. Our webinar series will be highlighting research and demonstration efforts from each of the 5 program areas. As you can see, our upcoming webinars will cover a broad range of topics, including novel coating systems for use in high-performance chemical resistance power top coats, high-resolution site characterization at chlorinated solvent sites, and tools for risk-based remediation of unexploded ordnance. The next Energy and Water webinar is scheduled for June 15th and will feature Mr. Chuck Hammock, who will talk about the, coupling geothermal heat pumps with underground seasonal thermal energy storage. You can find more information about our upcoming webinars at this link, and registration is now live for webinars through the end of May. And last but not least, I'm pleased to announce that for the first time since 2011, the CERTUP and ESTCP Symposium will be held this November in Washington, D.C. The three-day event will showcase the latest technologies that enhance DoD's mission through improved environmental and energy performance. Registration information is available on the CERTUP and ESTCP website. And thank you for attending today, and I hope you enjoy the webinar. Jennifer, back to you.
Thank you, Tim. And it is now my pleasure to introduce Mr. Kevin Marr, President of Power Analytics. Prior to becoming President, Mr. Marr served as Chief Technology Officer. Under his guidance, Power Analytics introduced industry-leading capabilities for energy management and pattern recognition. He is the author and creator of the Power Analytics Energy Alignment Process and has more than 15 patents in analytical processes. Mr. Marr has authored numerous papers on power, energy, and high availability architectures over the past 25 years, and he's led development organizations and provided strategic planning for companies. Mr. Marr was previously named as one of Green Tech Media's top 100 people to know in Smart Grid. He has undergraduate degrees in biochemistry and business, and a master's of business administration from the University of Colorado. Kevin?
Thank you, Jennifer, and good afternoon or good morning, depending on where you are. And thank you also for attending the seminar today, the webinar, and hopefully it will be both productive and informative as we kind of go through it. As Jennifer mentioned, I'm be presenting the SAMES microgrid as part of San Diego cluster, and just a couple of things to review on that. A great deal of the focus that we had in this program was microgrids for energy surety. The fundamental element there is that the ability to use existing generation and assets more effectively, including beyond stranded assets or just in emergency situations, is fundamental to part of the value proposition. I'll also discuss fairly extensively the concept of the power model. Some of you will be familiar with power modeling, some of you will not. So I will try to keep that discussion relevant and not overly focused on minutia that may not be important there. The San Diego Naval Base cluster, the SAMES cluster that we targeted with the help of NAVFAC Southwest, was critical to this, primarily because of the support and efforts of NAVFAC Southwest and their ability to be able to advance this innovative approach to using their assets inside there. In addition to that, they had done significant amount of work in a component of any system like this, which was a secure fiber optic network that existed previously that was a backbone of what we provided. Because we did not plan and did not do control at the naval bases, we also ran a mirrored site for pre-staging of software before it was put out in San Diego at the Colorado State University, at the Power House location, the Integrated Lab, with the significant assistance of one of the partners, Spray Technology. And then lastly, I'll talk about the conclusions. So a little bit more about the energy surety piece. The value of an economic value of a microgrid, we believe, and we tried to prove inside here, has two components to it. One is the element possibility for participation in markets, but also its part, a big piece of the economic value is derived from the ability to use as much of the existing infrastructure as possible. In fact, frequently microgrids end up being much smaller than would be desirable, largely because the cost to replace existing infrastructure can be prohibitive in terms of moving the system forward. So the power model for us is a critical component to that, and in particular our ability to be able to integrate those assets so that they're more than stranded assets, but never losing sight of stability and reliability as a key component to what's looking to be accomplished. So the SAMES team incorporated a number of different companies, obviously Power Analytics as the lead, Veridity Energy, Spray, and then OSI Soft, as well as Connor Networks. Our significant technical advisors were University of California at San Diego, and then of course SEG&E as part of this program. One thing to note inside here, as I mentioned, the Spray technology was integrated at the mirrored site at Colorado State, not in San Diego at the microgrid cluster that was using all of their existing infrastructure. So the configuration that I'll talk about is a little bit difficult to see in this slide, but fundamentally it's built on using the existing fiber optic network that connected all three of the bases, with the principal server being located at Naval Base San Diego. That process and that original approach was not intended to go down the path of DIACAP. So if you're familiar, I'm sure, with some of the secure questions, and I know that you'll hear a lot more about that as IP keys gets in here. This process began prior to the RMF process, so this still existed under DIACAP. The original intention was not to do DIACAP because of the demonstration period associated with it, which would exceed the demonstration period. But within 90 days of beginning the process, Naval Base San Diego in particular came to us with the idea that if we could integrate the Niagara server, Niagara technology, which was the basis of their underlying architecture from a secure perspective, that they would be able to bring us along in that process. And that was pretty fundamental, frankly, to also our ability to get data from existing systems. So you'll see that a lot of the data analysis is a direct result of that integration with the Niagara server in that secure environment. The power model, really, as I mentioned, is pretty fundamental to how we approach a system like this. And the basic idea of the power model is that it is designed to be able to tell you some significant information about the electrical infrastructure. Historically, most people are familiar with the benefits of a power model through specific deliverables that would be often referred to as a protective device coordination or a short circuit analysis, or more frequently, more commonly these days, an arc flash analysis. That's largely because the importance, obviously, of delivering power, the right level of power to specific locations is the requirement, is the fundamental need for a power network in the first place. But because of the loads, the generation, and the safety associated with it, power modeling technology has evolved over the years to be able to set protective devices in particular to a level that ensures that the system will perform to meet the mission that the system was designed for in the first place. Power Analytics takes that one step farther, and fundamentally what we did for the Navy base installations as well as at Colorado State, which is to take an existing power model and use that existing power model to begin creating a baseline understanding of exactly what's possible with the site. We ultimately integrate real-time data into the power model and use that to validate the baseline as well as create opportunities not only for optimization but address areas of operational efficiency, including simulation analysis that would allow the user of the system to be able to determine how the system would perform based on a number of different areas. So the less technical discussion about that would be to, for example, be able to see what would happen if I were to do the following, whether it's part of a training process, part of the operation, or part of a maintenance procedure. So the accuracy of the power model is pretty important. I would say that in any low, medium voltage system, certainly today virtually anywhere in the world, certainly the case on the naval, on any military base, the power model does exist. Its accuracy and its relevancy at the time that it's turned over varies pretty significantly depending on the mission of the base and the focus of the operations team inside there. So Power Analytics took the existing power models and began converting them into our software, the design-based software, as well as being able to update it based on fundamental things that we would learn about it. That process would look something like this. So this basically the screen you see on the screen, the image you see on the screen is a screenshot, as well as most people are familiar with electrical models being a one line, and that's the component that you see at the bottom of the screen that looks and is, for all practical purposes, a CAD drawing of the electrical system. The difference with the power model is that, unlike a traditional CAD model, the power model uses very granular information about all of the relevant components associated with the system. And that relevancy is extremely important. It includes things like how a generator is going to start, how a motor is going to start, and it's very specific to the electrical infrastructure associated with that load and generation inside there. So instead of being a number of different ISO symbols across there, each one of those devices has a library of information specific to the manufacturer that's modified by the end user for their requirements. So they basically look to provide a level of understanding of the power model that is appropriate for what it is that they're trying to accomplish. We take that power model, as I said, and typically take it several steps farther in order to determine, will the system perform under a variety of different scenarios, and then how will it perform, so we know not only where there may be some discrepancy with what's there, but what it is that we can do with the system. This screen is exactly the same screen that you saw on the previous screen, except that this is that same single line now implemented in real time. So the difference, obviously, is fairly significant from a user perspective, and what it represents now in this color scheme is that same single line information with circuits that are energized in red, circuits that are de-energized in green, and information about the power network, specifically such as what's the capacity of the network based on the infrastructure and the generation at that instant. And as power information changes, so the simplest one to think of is that a circuit breaker or a fuse or a switch, when you turn something on or off, fundamentally changes the topology of the power network. So when that happens, what the system does is rerun a power analysis on that change for whatever is appropriate and represent to the user what it should be doing at that instant. And if it deviates by more than a couple of percentage points, we know that there's an issue and we know why. So we would follow that up with a notification process about something going on inside there. It also forms the basis, as I mentioned, for a simulation environment where there's actually multiple copies of the power model, and the simulation environment lets a user or a trainer or anyone be able to go in and say, what would happen if I were to do the following? And the implications of that from a planning and an operation perspective are pretty significant and also very valuable relative to how the system operates. So the next piece of it is just some of the conclusions and comments about the real-time power model. And I will use this piece to kind of move a little bit quicker in the discussion to get to some of the actual testing and simulation, being cognizant of the 25 minutes that I've got to work here. So I should mention also that you'll see at the end of the seminar there will be opportunities to exchange information and provide more detailed demonstrations and discussions after this outside of the context of this webinar in order to keep everything moving quickly. But basically these are some of the areas that we looked at relative to the 3 Navy bases. This data and each one of the subsequent data in terms of the performance of the site was obtained through that secure network. So this is what the system was able to do, was integrate both high voltage and medium voltage and low voltage systems into the analysis capability as well as the building management system. So as I mentioned earlier, fundamental to the economic value of a microgrid is this ability to integrate multiple sources of data as well as to be able to do the control that's appropriate for the system through those systems if that's possible. So what we always look for is if there's additional analysis or data required, whether it's metering or control, can we do it through the existing infrastructure, or is there something that has to be added to that in order to make that happen? So this basically review is just of the total energy consumption at Point Loma, which is one of the 3, Naval Base San Diego with a specific focus on the medical center, and Coronado as the 3rd one, all in terms of their overall consumption as well as what that pattern looked like over the period of time that we used for the ESTCP demonstration. The mirrored site at Colorado State was important, as I said, from two perspectives. One is the secure environment, and is fundamental to any on-premise installation. Requires that the team has an ability to be able to test anything before it's deployed at the site, and had the additional advantage that the mirrored site at Colorado State University provided us the ability to do demonstrations of control without jeopardizing any of the mission-critical infrastructure in San Diego. So as you would expect, especially at the time that this ESTCP program started in San Diego, there's always a great deal of concern and reticence on the part of the operations team that you will impact the operation of the system. So the balance of selecting circuits to be used as well as how to demonstrate that are critical to the confidence that the organizations have as a way to move forward. And as Tim mentioned earlier, with the understanding that that all of these programs are at their best when there's future to them, when there's an implementation that goes beyond the demonstration. In the case of NAVFAC, I would say that certainly one of the most significant things that happened out of there was a new program that allows NAVFAC has engaged in beginning earlier this year to determine how best to address issues of existing infrastructure for exactly this reason, how to best incorporate it into the future of both energy management and of base surety. So the differences between San Diego and Colorado State are that the power model is different. It reflects exactly what's there, but it does use the existing infrastructure and it's integrated in real time. So a little bit of background on the Intergrid Lab, or the Powerhouse Lab in Fort Collins. If you're not familiar with it, it's a former substation from Poudre Valley Electric. I believe it is the largest engine lab in the United States, and it has a number of different components inside there that have been part of the curriculum for the university, and in particular how the SPRE organization has been able to provide both a teaching and a research environment that advances both distributed generation technology as well as fundamental concepts of the microgrid. I will also tell you that that while being able to island a microgrid is critically important to energy surety, it is not the most difficult piece, and it certainly is not the most economically valuable piece. Actually, the process of islanding is less complicated technically. It's really paralleling that can make the biggest difference, because that's the area that has the effect of not only reducing load or demand, but also in certain markets being able to actually participate in markets. So it is a fundamental approach to all of the planning for microgrids. The dashboard for the Powerhouse, or the main screen, all of the systems, the same system as well as here, looks significantly different than a power model does in terms of its electrical one line. So what you're seeing up here is that representation. That's partly because of the realization that these systems require a high degree of visualization, because you can communicate a significant amount to any operator, to any user of the system, if what you communicate to them provides a great deal of information without having to go through the process of converting data into some analysis function. So that's basically what you're seeing here, as well as some main dashboard information that included a thermal camera of the facility, as well as some video cameras. At the lower right-hand corner of the screen include things like the load shedding process, which was dynamically determined based on the current operation of the system, as well as our ability to turn the controls on and off, because this is a teaching environment, and we had to be very careful that we didn't try to do a demonstration or a control action that would affect any of either the students or anyone else working in the lab at that time. So in power modeling, in particular, the concept of scenarios is pretty important. That terminology derives specifically from areas that a power engineer looks at. So there were a number of different areas that were here. I won't go through them in all the detail, but there are other things that you would expect, like what happens when I'm utility connected, what happens when I have distributed generation of multiple types, still utility connected, when I island or when I have a loss of utility, as well as load shedding under loss of utility, and then the ability to operate the system on just renewable generation. So typically in that process, what the power engineer does is look at least normally the power flow as the most important first step, because the idea is that you have specific locations on the power network that have to deliver the right amount of power to that system to maintain that capability. The second set begins to cross over between the power modeling side of the economic value of the system. This is a capability that we refer to as power system optimization. It's more commonly known as optimal power flow. It's basically the idea that what is the most economic operation of the system based on variables such as the cost of the energy being used inside there, as well as other things that need to be maintained, most importantly, typically for a military installation on energy surety. So I want to maximize my economic value, but I cannot create a situation where I have potentially lost the ability for the system to operate. So this scenario under what we ran for the Colorado State piece looked like scenario number 3, so you'll see me talk about that a little bit farther. Anyway, then the significant challenges, I would say, relative to what it is that we were trying to provide inside here are, as you would expect, that obtaining the data, which has both proprietary information because it's about the system and can be fairly dated. So if a power network has not been modified to any significant amount for a period of time, it frequently is lacking significant nameplate data, as it's referred to, for the components on the network. We also typically uncover a great deal more about the system when we do the initial analyses, and none of that was completely consistent with our experience in San Diego. So the process of doing this usually involves an iterative cycle where we're going back to the site because the initial analysis says that something couldn't possibly be operating, and with an existing facilities like in San Diego, we know that that's not true. We know that the bases obviously operate and very efficiently. They meet their objectives. So if the analysis that we're coming up with indicates that that's not correct, then it's pretty obvious at that point that some of the data that went into the modeling is not matching reality. You'll hear that described both by us and by other folks that the reason for that is that frequently the power model and the analysis of the power system is critical to the initial design of a system, and then through the construction and installation process, there's frequently a great deal of modifications that are done, whether it's for value-added, essentially bringing out cost, or there's more practical components which say, we know that feeder needs to go here, but it's just not possible, so we're going to modify it. Those modifications can and do have a significant impact on the system. So if the system of record does not match the performance that we're seeing on the power model, it really is critical to solving that problem up front, because you cannot or will not be able to get essentially to the level of performance with the microgrid and any level of energy surety if that remains an unknown quantity. So the solution to that problem is obviously the increased accuracy of the system. Then that takes another level, because as soon as the integrated real-time data comes in, we learn an additional set, which is these are the values that we're seeing, and how does that represent with what we have previously on the power model. So both of those things come into play early on into the process. And then essentially what happens after that is the system just continues to learn. As the system grows and changes, the power model now becomes the basis for everything going forward. And in fact, can contribute significantly to the portion of the economic value of the system, which includes things like safety-related analysis like arc flash, because the power model at that point is essentially the result of what would look like a real-time site survey. So all the information is there at the touch of a button. Someone is able to download and obtain the most detailed information about the system. So whether you're involved with the existing system or talking about modifications to it, that becomes very critical. including from a planning perspective. So the economic basis for those, as I mentioned inside here, and that process, and keeping in mind that this is a demonstration at 3 operating bases. So the balance between getting additional information that minimizes the disruption to the operations staff is only possible with the support of the leadership. So the leadership and the relationship with the sponsoring agency in this case, or in any site inside there, is also critically important. Things will not move forward without it. It's actually not unique to a DoD installation. That's a common issue that we see with all of our commercial customers, where it is considered disruptive. It's also considered to be able to get information. It also challenges some of the assumptions of the operating personnel prior to that, because we're coming to them with what we learned versus what might necessarily have been there beforehand. And then lastly, these lessons learned from SAMES in particular directly impact a lot of the future planning process. And obviously, we've been much more involved with NAVFAC and the Navy than we have at other installations. But each one of these, all of these learning processes are consistent with all of our discussions that have kind of gone forward inside here. So anyway, I've now reached the end of my 25 minutes of the planned discussion. As I mentioned earlier, and as Jennifer and Tim mentioned, we'd be happy to provide additional information for you. I know that this program is available for review further, and we look forward to that opportunity.
Thank you so much, Kevin, for that excellent presentation. We do have a few questions for Kevin, and I would like to remind our audience at this time to submit additional questions by using the chat box on the left-hand portion of your screen. Kevin, the first question for you is, does there have to be a microgrid to participate in the energy market?
It's an excellent question, and the answer is no, there does not. The assets that you're looking to participate from a market perspective can and do and should be considered independent of the microgrid, keeping in mind that a microgrid has several advantages to an integrated power network. One is that how the system operates electrically can be transparent to the utility that's connected to it. In other words, there's a great deal of flexibility to be able to integrate multiple forms of distributed generation and load behind the point of common coupling, which would include things like solar, energy storage, spinning generation, but represent that back to the utility as just a stable system without having to engage them on it. But obviously, that encumbers the operation of the microgrid on the site that is on the customer side or on the base side of the point of common coupling. But those assets themselves can do and should be considered for market programs independent of the microgrid, because it increases the probability that you have economic value of the assets. And whether you start with that and ultimately get to a microgrid, if it makes sense, in particular from the ability to island or integrate multiple sources, puts you on a glide path that might be possible if the only way you think about market participation is through a microgrid.
Okay, thank you. And Kevin, do you have anything more to add about maximizing economic value in a given market? Like more
I think,
yeah. Oh, go ahead.
Yeah, I think that and I think this will be apparent in the second session that is coming up inside here. The market participation components of any site vary based on the geographic location, as well as are very dependent on things like environmental quality requirements, limitations inside there, as well as generation. It's normally the case that a lot of the most stable types of generation tend to be either emergency generation that was previously available, and frequently that emergency generation may look like a non-renewable energy resource, and that can both have limitations in its ability to participate as well as its value. But I would say that keeping the balance between economic value and power requirements are key to any of these programs.
Thanks, Kevin. Next question is, are there incremental steps that can be taken to move markets and energy surety?
Yes, I would say that, again, kind of building on that first question, it is always the case for power analytics when we have a discussion with anyone about a potential microgrid. The first question we ask is why you think you need a microgrid. What is specifically you're trying to accomplish inside there? Because very often the asset that is looking to be a participant has economic value but does not require the kinds of advanced controls and capability that you would see with a microgrid. So that's a very important distinction, and it also, as we said, represents the ability to move forward with a system without having to essentially talk about a pretty significant technical implementation of something like a microgrid.
Okay. And I would like to, one more time to remind the audience, if you have any questions for Kevin, go ahead and submit them at this time. And Kevin will also be back at the end of the webinar to answer additional questions. One more question for you. Could someone participate in energy markets on their own, or would there need to be a participating representative?
It's also a very good question. I would say that the answer to that question does also depend to a certain extent on the market itself. So the big advantage that being able to participate in a market with someone that is familiar with it is the learning curve. They frequently bring information about markets as well as what might be confusing from capability and requirements depending on which market it is that you're looking to participate in that may be prohibitive in terms of moving forward. In some markets, you absolutely must have a market representative. You must have someone that provides that because of concerns about performance in the market as well as some of the advanced markets that require pretty tight control over how a system operates. So you see those represented on macro scales with balancing authorities, and you see it represented on more localized scales, and in certain markets even more so. So California has certainly been a leader in some of the markets that they look to have participation in without requiring sophisticated capability, while others, like in Texas or at PJM, have more opportunity but also require a lot more communication, a lot more capability than you would see.
Okay, thank you very much, Kevin. Is there anything else you'd like to add before we move to our next speaker?
No, thank you very much for everyone, and certainly I would. The only thing I would add is that I would say that in the years that we've been participating with in various ESTCP programs, that it is an extraordinary program that really has advanced a lot of technology. I'm quite certain that the capability that the Navy is looking to is deeply in moving forward right now would have been delayed significantly and not well informed if it weren't for the value of the ESTCP program.
Excellent. Thanks again, Kevin. We'll now move to our next speaker, and the next part of the webinar will be presented by Mr. James Bach. Mr. Bach is a Chief Engineer at IP Keys Technologies with 30 years of industry experience in electrical power distribution, lighting, and information technology sectors. Mr. Bach has written standards for underwriters' laboratories and has performed engineering analysis of low and medium voltage power distribution systems. He has managed advanced concept technology demonstration projects, and he has performed system engineering for the DoD Joint Command and Control System. Recently, Mr. Bach led an IP Keys product development team of demand response and energy efficiency control systems. He has a Bachelor of Science degree in electrical engineering from the University of Illinois in Urbana-Champaign with a specialty in communications and control systems. Jim?
Thank you. IP Keys became involved with this market, this business area, about 10 years ago. The federal government decided to invest an incredible amount of money in infrastructure, in the electrical infrastructure, and this was smart meters and single phasers and all this kind of very things that would comprise the smart grid of the future. One thing came out and they said we need to have a single method for energy suppliers and consumers to be able to communicate in a machine-to-machine manner. It needed to be highly secure, it had to be very scalable. They want to talk to millions of people. It's not just a onesie-twosie thing. And that standard was known as Energy Interop, which you probably would know as OpenEDR2. We were contracted by NIST to build the initial system to do proof of concept of that standard. We've now commercialized that, and we've done a lot of pilots to prove that OpenEDR2 can be the single method of communication between the various stakeholders in the electrical market. The Department of Defense, unfortunately, has lagged in participation because many of these programs require a connection. ESTCP put out a topic that basically said we'd like to see how military facilities can participate in these markets. And so that's where you've got this mouthful of market-aware, high-performance buildings. So market-aware means they're connected to some energy market. It could be the wholesale market. It could be the local retail utility market. But they're connected and communicating, and there's a financial compensation for that participation. Programs have also sped up. It used to be that day-ahead notice with a telephone call was the way it was done. They now have programs that are cut down to 30 minutes. Some of them are even no notice. It's an immediate signal that goes out. Without automation, it's very difficult to participate. So when you want to be connected to your energy provider and receive these automated signals, the military networks, which are commonly known as the NIPRNet, have a very exacting method to get connected to. It's not trivial, and it's designed to protect the integrity of our networks. So they want to make sure that nobody could use your technology to get inside and do bad things to our IT networks. For this thing, the project objectives, there's a lot of interest in the Internet of Things, or Distributed Generation, or DER. And what this is these are devices that it's no longer the energy providers making power and the consumers just consuming it. People are generating their own power, as you just saw in the previous presentation, and there's a bi-directional interaction. There are times where it makes sense to consume power because the price is advantageous. There are times where it makes sense to generate your own power, and there's times where it makes sense to sell your power back to the program. So the question was, how does the Department of Defense facilities, primarily military facilities, how do they participate in these markets? What we've tried to do is create a roadmap or a way forward, a single methodology that other people can follow to go through this process and securely get that connection. We wanted to pave the way for automated demand response at the DoD. We wanted to give them a gateway. Now, a gateway is something that you can add to the existing infrastructure and facilitate it. If your system, you saw that they used the Niagara protocol and the Honeywell system so that they could use that connection request. But if you wanted to use the Johnson control system, you would have to go through that. The purpose of a gateway was, regardless of the system that you're using, you could have a gateway that would allow you to participate without changing the accreditation of the system that you already have. We wanted to give a roadmap to how to get through this process. It's not easy, and there's a lot of things that can really set you back. The companies who are not used to doing this kind of work and dealing with it, the Army accreditation process or the military accreditation process, it can be daunting. So I wanted to give some good points for anybody that wanted to get through this later. We wanted to create that paper so that future people can follow that. We wanted to give insights, show the potholes, find the areas that would keep you from being able to get through, and then create a guide that would give you an idea of economically what that would be worth. Now, IPKeys Power Partners is a division of IPKeys, and that does aggregation, demand aggregation. So if you wanted to participate in a program, you would contact somebody like us, and we would tell you what programs are suitable, what the requirements are, what the potential payouts are, so that you could go through that. And to answer the question that he answered, some programs allow you to enter in all on your own, and some programs require a middleman. So like the wholesale programs typically require somebody in between, a demand aggregator. But a lot of the retail programs, like SDG&E, you can connect directly without a demand aggregator. The question is, what is this energy market information value? What we found is many microgrids, if they have a connection to the local market, can add into their thinking the price of energy out in the street. Does it make sense right now to use my local generation, which costs 20 cents a kWh, or buy it from the utility at 4 cents because it's in the middle of the night? Having that visibility so that your system can automatically make these decisions allows the economic value of the installed system to greatly increase. You know, it's not just about how long does it pay, is my facility more sure because I can island, but it's how do I find another revenue stream to allow me to invest in my infrastructure and still be a benefit to my community. In other words, be able to supply power when it's needed. If you're going to connect a device to the DoD network, the first question you're going to run into is why. This is not your house where you can put in a smart plug or lights that are controllable from your iPhone. This is the military, and they're going to look at it and try to decide, is this connection worth the risk? And they have a very established methodology to decide if that is. The second question was, does it compromise the mission? And I'll get into what the mission really is. Then, does it meet a real need? Whose need are you? If it's just cool, it's a lot harder to get through than if it actually satisfies some requirement that they've been tasked to fulfill. And is it cyber secure? When you're talking to the Department of Defense, you're going to hear the word Title 10 responsibilities. And they use it frequently. What that means, very shortly, is their responsibility is to protect this country, to keep us from being attacked. Saving energy, making a profit, none of these are a concern for the Department of Defense. It's protecting the country. Anything that can impact their Title 10 responsibilities will never get anywhere. So you've always got to look at, how does this affect their mission? In order to connect to a Department of Defense network, you're going to need two things. You're going to need an ATO and an ATC. And these terms are, the government loves their acronyms, but these are the ability to operate on the facility and the ability to connect to their network. And those approvals come through a whole process. It used to be called DICAP. It's now called RMF. The principal difference is DICAP was a 3-year accreditation, and RMF is a variable accreditation. It's all based on what is the risk potential of your device or your system. One of the first things we ran into was buy-in. You're talking to the facilities manager, the person who takes care of making sure the lights and the air conditioning, everything works. In the Department of Defense, that is not the same as the installation commander or the commanding general. Remember, their job is to protect the country. So any weapon system, any other thing, those get high priority. But putting in a new building management system and wanting to connect to the network to participate in a program, that may have a much lower priority. So you have to get the system owner. Every system that you deploy on a facility needs to have somebody who's been charged to maintain the system. If it's a computer-like system, somebody to check the security log, somebody to do the updates. They have to get somebody locally that has agreed, this is what I will do. You've got to get the network people, so they're typically called the NEC, Network Enterprise Center, but those people are the people who guard the network. And ISSM is your security manager, and he's the one who will make the decision to allow you to connect or not. You may get through all of the systems and get your ATOs and ATCs, but if you try to connect to a network in Fort Meade, which is the people who do the NSA work, they will never let you connect. The ISSM can say no connection allowed, period, just because he believes it's a risk. And then you're going to connect to your local energy provider. You need buy-in from the utility. If the utility isn't running programs or they're not willing to accommodate the special needs of the military, it may be more difficult to get something that works for both sides. I've gone through all of these already. For this, Internet of Things kind of idea, the connection of things, it's a device, and you're certifying a device. If it's software, it needs to run on something, and that something is going to be part of your accreditation. So that hardware, you may write a software application, but if it needs a piece of hardware to run, because they're going to ask you for the complete system, remember that they are looking at everything, not just your software. What we found when we brought our normal hardware that we use to connect to facilities like factories or businesses is they don't like single board computers. They don't like that. They're thinking laptop when they're accrediting. They're thinking server. And so what we ended up doing was finding a device somebody else makes, hardware, that's already been through the process. So we took our software and put it on someone else's hardware to allow us to get through the system. Remember that your software security is based on updates and patches. So when a new threat comes out, you must be able to patch your device. If your system is such that it's built and not remotely patchable, you may have difficulty managing your future security risks, and that will be a vulnerability. So finding a way to keep those updated in a timely fashion is very important. It's also important that you monitor the threat environment and notify the government as soon as you notice a vulnerability for your system. What we find is if you want to get through the network, if you follow a standard request response, and so if you're not an IT person, that's the exact same way that your computer browser works when you go to a web page. You click on a link, you've made a request, and then the link responds with the web page. That request response is designed, the firewalls look for that. And if it's ever something that comes in without being requested, firewalls will almost always block it. So it's very important to do the request response. When our device, natively, the commercial device, ran Debian Linux. And that's a very nice choice. It's very lightweight, and it's not typically a target for hackers. Windows is a huge target for hackers. However, the government has many, many, many Windows issued laptops out there. So they are very adept at keeping their Windows laptops up to date and hardened. So if you want to use a not recognized operating system like Linux, Angstrom, Raspberry, all of these kind of very nice, lightweight operating systems, you will be forced to support it, which means that unlike Windows, where Microsoft will support it, you have to support it, and you have to go through a support plan. We were told during the accreditation process that this is basically going to make it crawl to a halt. So we took our system, which is Java-based, and moved it to a Windows operating system. They're going to scan your application for vulnerabilities. They're not looking at, does your system work? They're looking at, can someone use your system to break into the government networks and do bad things? So they're going to scan it Nessus is the current tool that they're using. You can purchase it yourself and get the virus definitions and all the attack vectors and scan your own stuff before. There are also companies who will help you with this process that will help you get through the accreditation. There's also what they call STIGs, and this is a guide that's going to tell you what you need to do to the operating system to make it so that it is compliant. Now, DISA, the Defense Information Systems Agency, has already configured operating systems with the STIGs applied that you can download and apply your own license key to. So you can get them pre-STIGged if that's helpful to you. Your ports, they're going to expect everything to be closed except what you absolutely need to work. Ports, finding ports that are left open are a favorite exploit of people looking for it. There's machines out there that are constantly scanning networks for open ports to find a way into the system. So you need to let ports are open, and closing the non-essential ones are key. Encryption. You have encryption for a couple of reasons. Number one, many people believe that this is personally identifiable information, meter data, control signals. They believe that it's PII, and that's covered by law that you must safeguard it. It's like somebody's social security number. If somebody broke into your database and got the social security list, you have to tell the people that that's happened. So you need to encrypt and authenticate. Just a simple open connection like your browser going to a website is not secure enough to allow this kind of exchange of information. You need something what they used to call SSL or TLS, or the green bar on your browser. In retrospect, it took us 2 years to get through this process. Now, once you actually get through the process and get your device hardened and vulnerable and taken away all the vulnerabilities and any exceptions that you're making is well documented, when you hand it to the government, it's actually a very short process. It can take a few months. It's getting them to accept your device for certification. What you'll find is they know once it gets into the list and they start working on it, the time to deliver that is tracked. But all the preparation time is not. So if you find a friendly ISSM at a facility that you're trying to get a connection through, they will help you before you submit. Look at things. They'll review your product and they'll say, this is going to be a problem. You're going to get to work on that. So you're looking for somebody who can really help you through the system. The next steps are, we're doing this at Camp Pendleton, which is in the San Diego area, very similar to where Kevin is. And they're going to deploy their device this summer. They're going to participate in the Southern California, or no, I wrote this wrong. They're going to be in the SG&E's capacity bidding program, and the estimated earnings for them are about $67,000 a year. California, Hawaii, and New York City are some of the areas that will help fund the infrastructure improvements to be automated. And in California, there's a $200 per kW incentive that you can apply for and receive. What we'll end up doing when this is over is we will have an accredited gateway. So if anyone wanted to have an OpenADR 2.0 device that they could put on their network, they would be able to reference that accreditation. It also gives the people who are going to make other devices the ability to follow our path and see where to go. So there will be a complete write-up on exactly how you get your accreditation for this device. Camp Pendleton will be in the SDG&E market performing this summer. Another area that's doing it, Fort Irwin, which is in the desert, will be in the SCE program next year in a lighting program. Okay, I'm open for questions.
Okay, Thank you so much, Jim. We do have a few questions for you, and again, I'd like to remind the audience to submit any questions for Jim at this time through the chat box. The first question is, what is the value of energy market participations in other areas of the country?
So, as Kevin said, this varies significantly, but a general rule of thumb is if you are in an emergency demand response program, and that's probably the first place that you would start. That's where they're going to ask you to curtail, reduce your consumption, and it's going to be very infrequently. It's when it's a bona fide emergency, and the value of that is about $100,000 per megawatt. It's a little higher in other areas, but that's about the round number.
Okay, thank you. And could you repeat the market that Camp Pendleton will participate in?
It's going to be in San Diego Gas and Electric. They're going to be in the local utilities market.
Okay. Thank you. Could a person use a diesel backup generator to participate in DR programs?
That varies by area of the country. In general, 10 years ago, the answer was absolutely. And there was an EPA rule that said you could run them for 100 hours. That was recently overturned, and it's been limited to the device must be able to run within the hours permitted by the air board of your area. I can tell you in California, they're eliminating all diesel generator participation. However, Texas is still quite open to it, and New York City is still open to it. So there's different areas of the country you can still use your diesel backups, but you're going to have to go through what they call the Rice-Neshap audit, which is going to determine is your system clean based on the rules that it has to be for the time. That may require you adding a catalytic converter depending on the year that it's made. It's a very involved process to figure out exactly what you do. And if you needed somebody to tell you what it is, we work with companies that do that. You can contact me after this, and I'll give you some references of people who can tell you if you can run your generator or not.
Okay, thank you. Can someone just use a separate network to connect to the public internet on DoD facilities?
They can, and that's been done frequently. What you run into is when you touch something in the DoD facility. So if your equipment was freestanding and all by itself and it never communicates to another Department of Defense network, using a cellular gateway or bringing in your own internet line is certainly a way to do it. The question that we were trying to answer was, we wanted to have a system that was secure enough to use on the line, but not necessarily say that's the best way to do it.
Okay. And what would happen if a DoD facility cannot participate in a program that they are enrolled in?
So that, again, varies by where you are in the country, and if you look at a map of the United States, it gets easier as you go westbound. So on the East Coast, you've made a commitment, you're expected to perform. On the West Coast, opting out is a very real thing. So you see the variances. However, most, not all, but most programs, you will never have a penalty that is greater than your earnings. So the problem of non-performance is just that you don't get the check.
Okay, thank you very much, Jim. And Jim, is there anything else you would like to add before we move to some more general questions with both of the speakers today?
Absolutely. So if any of the people who are attending are interested, I was surprised at the amount of interest in the energy markets based on the questions with Kevin. If they wanted to know what does my facility need to do to participate, I'm in Virginia or I'm in Illinois, what are the options here? They can call us up at my contact information, and we'll give you a very quick overview on exactly what your options are. That's all.
Great, thank you, Jim. Okay. At this time, we'd like to bring Kevin back, and we have some questions that we'll invite both of our speakers to comment on. The first question is, we'll start with Kevin, and the question is, are there civilian and commercial programs that are paralleling the direction the DoD is moving in these areas?
Great question, and I'm sure that this will also be a great place for both of us to be able to talk about. There's was mentioned a little bit, a few minutes ago by Jim. There are several areas of the country that are more aggressive and progressive. Certainly, both in terms of the ISO locations, like in Texas with ERCOT, as well as PJM, and many people are probably familiar with the advanced work that the New York State has been trying to do, beginning with what they refer to as the New York Revised Energy Vision that has garnered a lot of information. California has always been a leader, and certainly Hawaii is a leader. And I don't mean to leave out certain states, but there is a concerted effort across a lot of areas to find economic value to increasing distributed generation, not only because of the ability for a location to be able to offset some of their energy costs, but because it has the potential, obviously, to significantly increase the reliability of the overall grid if it is a managed distributed architecture as opposed to the traditional center capability. In addition to that, I would say that you'll also see pretty significant areas of focus, including by utility companies that are looking to defray capital expenses, because things like additional generation or transmission lines, even distribution lines, can be extremely expensive, especially in large population centers. So the value of distributed generation goes far beyond what might be perceived of as just a way of reducing or increasing renewable generation to reduce some levels of pollution. So there's quite a bit going on, and probably accelerating over the past 2 years.
Okay, thank you, Kevin. And Jim?
Mm-hmm. Kevin was very, very well covered that. I have nothing to add.
Okay. Jim, we'll start with you for this next question. How has the dramatic increase behind the meter generation resources impacted the stability of the grid?
It's made it worse, unfortunately. What we have is an incredible high penetration of behind-the-meter assets that are not under the control of the utility, and they react in ways that are not easy to forecast. We're currently in a Department of Energy pilot with National Grid, which is up in the New England area, to find a way to use the same technology I talked about to balance high penetration solar. So when you start getting areas where your solar generation exceeds 30 to 40%, you end up with more power when you didn't want it, not enough power when you did, and you become increasingly reliant on it. Now in Hawaii, this is a big problem. As you would imagine, Hawaii is quite sunny, and they're having to run, I believe, a 160-watt fuel oil generated sink reserve program in order to balance the solar intermittency. So they're one of the leaders in finding better ways to do it than just running big backup generation to make sure that if the solar goes away, the lights don't go out.
Okay, thank you, Jim. And Kevin, did you have anything to add on that question?
Yeah, I think as Jim indicated, that's absolutely correct. One of the things that is easy to forget about power is that the infrastructure that we're all familiar with was derived as a generation and consumption capacity market, where power was generated in one place and it was used somewhere else. So we've developed a huge amount of capability to be able to react very quickly to those instantaneous changes in load, because the generation has to follow the load. With the advent of distributed generation, it creates fundamentally a problem that is reverse power flows, as everybody's familiar with. So the system was not designed to be able to handle that. And despite what may seem like intransience by a lot of traditional generation and utility companies, there are real problems. as Jim was referring to, that as you increase the capability from a distributed generation on that environment, you do decrease the reliability if you're not cognizant of what that is, or worse, you're putting the utility in a situation where they have to increase their investment in fast-acting generation, because if your system goes away for whatever reason, that creates a problem for them, and they have to be able to support that. So the idea of situational awareness, not just on the base, but with the utility partners, is critical to all of this, and understanding that it is a partnership.
Thank you both. And again, I'd like to remind the audience that if there are any questions for either speaker, there's still time to submit those questions, and even specific questions can be asked at this time. We did receive one question specifically for Jim. What would you estimate was the cost for obtaining an accreditation for your gateway? And what do you estimate the cost would be to get approval to install and operate your gateway at a new Navy or other installation?
The actual accreditation provided by the government is free. So they don't charge for that service. There's no fee to pay to do it. The estimated cost to get our product from a commercial place to a full DOD, I would estimate it around $30,000. Now, the actual device costs $3,000, and any person who knows how to plug in a wall socket and a Category 5 cord could install it. So the actual cost to deploy it is about $3,000.
Okay, and how much time should you plan to gain approval to install the gateway at a new installation?
You should give it at least 6 months.
Okay, thank you. The next question is for Kevin. In what ways are technologies like blockchain, energy storage, and others changing the landscape for distributed energy?
Thanks, Jennifer. I would say that consistent with your earlier question about how things are changing commercially, there's a significant amount of activity around looking for very specific ways to monetize the value of distributed generation in ways that go beyond even the current market participation, largely because the markets themselves, in many cases, were developed or advanced based on the current capability of the systems, and it's obvious to people that are outside of our sphere, our world, that a lot is changing in the world of traditional markets, and the analogies of what's happened to everything from areas like transportation in as well as hotels, and everybody who has a millennial, as a lot of us do, including me, is aware of the fact that there's an expectation that things should be moving faster, not slower. So what is it we can do? And these advanced technologies that are being implemented now really mirror a lot of what the Department of Defense has been trying to promote for a significant period of time, as well as other agencies, including the Department of Energy. As Jim mentioned, specific programs like the Sunshot Initiative have dramatically advanced what's going on the solar side of the world, and then the idea that that's creating some potential instability because of the intermittency and the unique capabilities of solar hasn't stunted the areas that people are looking for to find new ways to monetize that. So again, I'd say one of the most famous of those is probably what's going on in, or at least some of the top ones that are going on in New York right now as part of New York Rev.
Thank you. One additional question for you, Kevin. Does your technology specifically facilitate participation in energy markets? And if so, would you please explain how?
Yes. So also a great question. Our technology is really focuses first and foremost on the performance of the power network, which is always associated with the surety side. So no surprise that our technology was first implemented in areas where availability of the system was the primary mission. So a lot of Power Analytics early customers were folks like the Federal Aviation Administration or the air traffic control centers, where a momentary interruption in power could result in the loss of knowledge of the air infrastructure and obviously the risk of life that's associated with that. In addition to that, the next set of customers for us were customers who are involved in very high availability, such as data centers, and for example, in financial data centers, if you cannot process transactions, the availability of that is immediately impacts, and many people know those, have heard or lived some of those problems from most recently what happened with Delta several months ago in terms of the loss of their network on down. So a lot of our focus has been about the performance of the network. Where that extrapolates to the markets specifically is that in order to operate most efficiently on a facility, the knowledge of the network is paramount to what's going on. If you think of a parallel such as your internal office network, your internet network, one of the things that's evolved fairly significantly over the years is that devices and systems have been created to make sure that your balance is there, or at least you know what the performance of the network is, and there's frequently a dedicated staff to make sure that you're getting the upload and download speed from your system because no one wants to tolerate an interruption. Power is different. Power will operate whether the device is communicating correctly to the control system or not. Because of that, you have to take much more aggressive approaches to understand what's going on and what's capable so that you can anticipate that. And that anticipation leads first on the first level of economic value and market participation just based on the cost to do that. But beyond that, in order for the system to participate in markets, you have to be able to demonstrate the knowledge of how the system will operate as part of it. In fact, one of the most common requirements for market participation with a microgrid is a process known as an interconnect agreement. And an interconnect agreement is exactly that. It's frequently providing back to the service utility very specific information about what it is that you're going to do and why they should believe you know that your connection at the point of common coupling will operate the way you expect it to, because if it won't, it either elongates significantly the interconnect agreement process or makes sure that it doesn't happen. So it's the markets are running in parallel with the technology to generate power stably for a secure environment, which is always a concern from a DoD perspective.
Okay, thank you very much, Kevin. And I have one last question for each of you, and that is, what is the main message that you would like to leave the audience with today? And Jim, we'll start with you.
My main message is that participation with all of this new technology in the energy markets can significantly shorten the payback period. You're many times putting this infrastructure in for energy security, but in normal peacetime operation, the military does not have a lot of extra money around to build infrastructure. Having a revenue source based on things that you're doing can significantly ease this process.
Okay, thank you very much. And Kevin.
I will actually build on what Jim just said. I think they're excellent points. As frightening in many cases as the technology can be, in particular when you talk about power, because power does kill people, the value of the economic value of that infrastructure goes far beyond a lot of the current thinking, and the ability to get to an economic deliverable with a system not only fundamentally accelerates, as Jim mentioned, but it also represents a very real roadmap that has quantifiable goals for everybody, including the ability of the Department of Defense locations to be able to support their local communities in areas that are yet to be articulated, but clearly dependent on this idea that using an asset for more than just emergency or standby capability for the system has great value to everyone that uses electricity.
Wonderful. Thanks both to Kevin and Jim for the very informative presentations today, as well as answering so many questions. The next webinar in this series will be on Thursday, May 4th, and it will be on the novel coating systems for use as high-performance chemical resistance power top coats. The webinar will feature 3 speakers, 2 from the Sherwin-Williams Company and 1 from the Naval Research Laboratory. Registration is open for this webinar, so please visit the CERTIP and ESTCP webinar webpage to register for this and other future webinars. Before we conclude, I would like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it if you could please take a moment to complete the survey that will pop up on your screen at this time. And this concludes today's webcast. Thank you.